This video for section 5.1 is going to be very, very short, but just know that the next video for section 5.2 is going to be a lot longer. Since this one is so short, I'm going to work through the practice problems 1 and 2 within this video, since those two pertain to this section. So here we're going to start talking about normal distributions. When we're talking about a normal distribution, we're talking about a curve. Let me see why this is, get this to annotate. There we go. So we're going to talk about a curve that is single peaked. So we only have one peak, which means that we only have one mode. We can also see from our curve that it's bell-shaped. And it's going to be symmetric. So one half of the curve is going to be symmetric to the other half of the curve. We can also say right in the middle of this curve, we're going to have all three measures of central tendency. So we'll have our median, our mode, and our mean. We can define the shape of our curve two different ways. So we're describing it by the mean and the standard deviation. And I'm going to use the two curves that are on here for reference, not that paranormal one, that was just for fun. But notice that most of our data in this curve over here, the one that I drew, is centralized in the center. So we're going to say that our standard deviation is smaller, right? Less data lies away from that mean. Whereas we can see in this curve that it's a little bit more spread out. So it's not quite as high of a peak like our other one. Our other one is more like this. So I overlaid that. This normal distribution is a little bit flattened. So we're going to have a larger standard deviation. We've seen that before whenever we were talking about measures of central tendency and measures of variation. Where the shape of the normal distribution is coming from is we are generalizing a shape of a histogram. So let's say here, if this was the shape of our histogram, we could say that we have a general curve, right? So the curve is created by generalizing the shape of that histogram. Let me clear this just to talk about one other thing. Remember, if we're talking about the shape of a histogram, right, we know, and I'm not going to draw that all out here, but we know that all of the bars in that histogram represent 100% of the relative frequency. We could say the same about our curve. So the area under the curve is 100%, or if we wanted to give it in decimal notation, we would say 1. I'm going to go ahead and move on to the two practice problems, first two. So if we look at number 1, it says circle all of the following statements that are correct. Keyword here is all. So we want to circle all of the following statements that are correct, looking to describe our normal distribution. So if we look at the first one, it says a normal distribution is any distribution that typically occurs. We cannot say that that is true because we could have skewed data sets. So we do not want to say that this one is true. We can see though that B and C, right, we have the bell-shaped and we have one mode. So both of these are going to be correct. Looking at that next one too, it says the mean and median are equal. That is also correct because remember that our mode is equal to the median, which is equal to the mean in a normal distribution. Then it says in a normal distribution, the standard deviation is 0. So we cannot say that that is the case. If we were going to have a standard deviation of 0, then all of the data is going to lie at our mean value. So we cannot say that this is true. The shape is determined by the standard deviation, but we cannot say that the standard deviation is 0. Looking at number 2, it says, state whether the distribution of values is likely to be a normal distribution, and then say why. So remember that different scenarios could occur here, right? We have skewed data sets, we have normal data sets, and we have uniform data sets. So if we look through these different scenarios, we can see in A, the numbers resulting from spins of a roulette wheel. We have 38 equally likely slots. So since they're equally likely, each one is going to have the same probability of occurring. So this is actually going to give us just a uniform distribution. If we're saying this is the probability of occurring, and this is the number that it could land on, each one has that same probability since it's equally likely. On B, it says weight of adult male manatees in Florida. So if we're looking at this, we're going to say, we're going to look at the weight. And the frequency. We know that most of the manatees are going to have roughly around the same weight, right? Adult male manatees. But there's going to be a few over here that are maybe lower. And then a few over here that are maybe higher. So we would say that this is a normal distribution. And we could explain, you know, some are going to be lower weight, some are going to be higher weight, but in general, they're going to be around the same mean, the same average, the same weight. Same thing on a score of a test of memory recall. So we could say most people are going to remember about the same amount of information. You're going to have some that remember more, some that remember less. But in general, most of the people are going to score about the same. So they're going to be in this range. So we would say that that is normal as well. I'm going to go ahead and end this video here, and then we'll pick up in section 5.2 in the next video.